Hi guys, I'm myself GANA SHIVA, and today we're gonna discuss on the concept of electromagnetic and its application, and concepts of light charge and sheet charge, volume charge, and Gauss law and its application. These are the agenda of today class. And firstly, concept of electromagnetic and its application, and next. This electromagnetic radiation is a transmission of energy through the interaction of electric and magnetic field. Here, the electromagnetism is a branch of physics, and it deals with an electromagnetic force, and that occurs between electric charge particle, where the electromagnetic force is one of the four fundamental forces, and exhibits electromagnetic field and exhibits electromagnetic fields, such as we know that such as magnetic field and electric field and light. Here the electromagnetic spectrum encompasses a wide range of frequency and wavelength, from radio waves to gamma rays, sorry. Applications of electromagnetic radiation, we know that, include communication system, such as radio and television. These are one of the main applications we can watch in the electromagnetic radiation. And here next, medical image. To check the medical image, like we have X-ray and whatever, such as X-ray and MRI, ECG. So such things gonna be work on the electromagnetic concept. And energy generation, such as solar panels. These are the one of the main applications we can watch in the electromagnetic resources. And we can image, see in the right side, we have an image how that electromagnetic spectrum will works on the each object. And next, electromagnetic induction is the process of generating electric current in a conductor, by varying the magnetic field around it. By varying the magnetic field, we can conduct and generating an electric current in the conducting by varying the magnetic field around it. And Faraday's law of electromagnetic induction states that induced electromotive force, EMF, electromotive force, is a professional to the rate of change of magnetic flux. That is the rate of change of magnetic flux with proportion, that is called induced electromotive force. And applications of electromagnetic induction, including electric generators and transformers and wireless charging technologies. We have, right, direct wireless charging technologies. And we can observe electromagnetic induction. This one we have that first electromagnetic principle, which is Faraday and electromagnetic induction. This is the first electromagnetic principle, that is Faraday and magnetic induction. And next, we're going to study concept of line charge, sheet charge, volume charge. And here concept of line charge. Here line charge refers to a distribution of charge along in one dimensional line. Here line charge will be works on the one dimensional line. Here the charge is assumed to be concentrated along an infinitely thin line. At the thin line, we can assume that a concentrated charge in the line charge process. And here it represented by symbol, we know that lambda, and has unit of coulomb per meter. It is that line charge having the coulomb per meter, that is unit for this one line charge. We can observe at the right side charge distributions. At the volume charge density, we have rho v. Rho v is nothing but the volume charge density. Here a limit del v tends to 0. delta V tends to 0, and del Q by del V is equal to dQ by dV, and we know that coulomb per meter square is unit for volume charge density, and total charge in the volume we have Q is equal to a limit V from rho V dV, and we have observed here. And yeah, next, the concept of sheet charge. Sheet charge refers to a distribution of charge over a two-dimensional. See, in the line charge we have one dimension. Along the charge will occurs along the one dimensional. Here we have the charge over two-dimensional surface. That is called the sheet charge. And here the charge is assumed to concentrate on infinite thin surface. There is a single thin surface. Here infinite thin surface we have in the sheet charge. And we have some equations. See, it is represented by symbol sigma. There the line charge will be represented in a lambda, and here the sheet charge will be represented by lambda. No, sorry, sigma, and has a unit coulomb per square meter. There we have a coulomb per meter in the line charge. Here we have a coulomb per meter square in the sheet charge. And see, we can observe the same equation what we saw in the line charge. And we have next concept of volume charge. Volume charge refers to a distribution of charge within a three-dimensional region. Within a three-dimensional region we can observe, we can reverse that volume charge, and the charge is assumed to be uniformly distributed within the volume, and uniformly it will distribute the charge within the volume. And we can represent the symbol rho and as a unit of coulomb. And what we saw the before figures in the line charge and sheet charge, those are really relevant to volume charge density, and it is represented by sigma, we know that rho, and as unit of coulomb per meter square in the volume charge. And note, these concepts are fundamental in electrostatic and are used to calculate electric field and potential in the different charges. And next we have Gauss law and its applications. And the Gauss law and its applications. Gauss law is a fundamental principle in electrostatics. It's a fundamental principle, and it relevance the electric field through a closed surface to the charge enclosed by the surface. And we can the mathematically Gauss law is expressed as the electric flux through a closed surface is proportional to the charge enclosed divided by the permittivity of media. And we can have the applications of Gauss law here. Determination of the electric field. Here we have the applications. The Gauss law is used to calculate the electric field due to symmetric charge distribution we have. And next, what we have symmetric distribution, and we have the cylindrical symmetric and the planar symmetric. This if simplifies the calculation of electric fields for highly symmetric systems like spheres, cylindrical, and planes. These are determined of the electric field, and Gauss law helps in the understanding the behavior of electric field near conductor and insulators. And that's how we know it will conduct. And this is for the today class, and thank you for the watching, and do like my video. Jai Shri Ram.